Module 3: Extraction and Isolation of Quinine. Quinine is an alkaloid which is used as antimalarial agent. The alkaloid occurs in the bark of Cinchona species. Among the species commercially exploited in India for quinine production are Cinchona ledgeriana, Cinchona succirubra, Cinchona officinalis, and Cinchona robusta are their hybrids. Besides quinine in Cinchona, about 20 alkaloids have been reported, important among which are quinidine, which is an isomer of quinine, and cinchonine and cinchonidine. Cinchona cultivation is undertaken in Tamil Nadu and West Bengal, and 2 government factories manufacture quinines. Cinchona alkaloid occur in the bark in combination with arsenic acid, and it is necessary to liberate them from these natural sites in order to facilitate extraction by immiscible solvents such as chloroform, benzene, toluene etesta, and mineral solvents. The 2 quinine factories in India are following century-old open type of extraction using mineral oil as solvent. The process in brief is as follows. Cinchona bark containing about 12 to 15% moisture is ground to a fine powder in disintegrators. The bark powder is mixed with cheap alkali, slacked lime containing about 60% of calcium hydroxide, and water. Lime fixes up the organic acid as insoluble calcium salts. The mixing is done thoroughly to mechanical mixtures, and the mixed bark powder is kept for 24 hours. The bark lime mixture is changed into extractor where a sodium hydroxide solution is added and stirred well. The bark lime caustic soda mixture is kept in the extractor overnight and extracted with mineral solvent at a temperature of 190 degrees Fahrenheit using steam. The hot extracted oil containing alkaloids is shaken up with dilute sulfuric acid in lead lines tanks for transferring the alkaloids present in the oil to the acid. The oil free from the alkaloid is recycled to further extraction. The sulfuric acid layer containing the alkaloids is boiled in lead-lined cylindrical tanks and filtered through filter press. The hot and clear acid liquor is neutralized with hot sodium hydroxide solution to pH 5.5. On cooling, crude quinine sulfate, grey colored, is crystallized out and centrifuged. Crude quinine sulfate, which is admixed with other Cinchona alkaloids and resinous matter, is refined by boiling with water and activated carbon to obtain pure white quinine sulfate, which conform to pharmacopoeial standards. The mother liquor containing other Cinchona alkaloid and little quinine sulfate is treated with sodium carbonate and sodium hydroxide solutions till precipitation is complete. The mixture of alkaloids called Cinchona febrifuge is removed, washed with water, dried and powdered, Cinchona febrifuge is fully utilized in the factory for isolation of quinine and quinidine present as sulfate. The quinine sulfate is sold as such are used as a starting material manufacture of quinine base and other quinine salts. Besides this, industrial method for quinine isolation of other cinchona alkaloids for academic and other uses may be undertaken by the following general outline procedures. Finely powdered cinchona bark is mixed thoroughly with calcium hydroxide, 30% of its weight. Then sufficient quantity of 5% solution of sodium hydroxide is added to make a stiff paste. After that, it is subject to Soxhlet extraction using benzene as a solvent. Thus we get benzene extract. The benzene extract is agitated with the organic extract with successive quantities of dilute sulfuric acid at 60 degrees until extraction is complete. All the acid extracts are combined together while still warm. Adjust pH to 6.5 with dilute sodium hydroxide solution. Then allow it to cool. On cooling, the crystals of quinine sulfate gets separated out. They are subjected to purification by recrystallization with ethanol using charcoal to decolorize it. The mother liquor containing remaining alkaloids add sufficient alkali to precipitate the alkaloids. The precipitate that we get is dried at low temperature and then extracted repeatedly with small quantities of ether. Thus we have two types of solution. One, more soluble ether portion, and two, sparingly soluble ether portion or ether insoluble portion. This contains cinchonine. This on purification and distillation give us the alkaloid. In this charcoal is used for decolorization purpose. In more soluble ether portion or ether soluble portion, cinchonidine and quinidine are present. They are agitated with dilute hydrochloric acid and thus the alkaloidal hydrochlorides goes in aqueous acid solutions. This aqueous acid solution is treated with strong solution of sodium potassium tartrate and allowed to stand and then filtered. Then add aqueous alkali. We get a filtrate which contains quinidine and aqueous alkali is added to other portion. On addition of aqueous alkali, free cinchonine base is collected, dried in vacuum at 40 to 45 degrees centigrade, washed with ether to remove traces of quinine and subjected to purification by recrystallization from ethylene. The filtrate containing quinidine is treated with potassium iodide solution and allowed to stand for a few hours. After that, it is filtered and the precipitate is collected. The precipitate contains quinidine hydrochloride. To this, dilute ammonia is added and thus we get free quinidine base. This is subjected to purification by dissolving in acetic acid, decolorizing with charcoal and reprecipitation with ammonia, and recrystallization from boiling ethanol gives us the alkaloid. Thus, in the sparingly soluble ether portion, we get quinine and cinchonine, whereas in the other portion, we get the other alkaloids. Because of number of side effects, usage of quinine has become limited in general malaria treatment. The alkaloid, however, still find use in cases where the parasite of malaria is resistant to synthetic drugs. Module 4: Extraction and Isolation of reserpine. Reserpine is an alkaloid of indole type having antipsychotic and antihypertensive action, which has been used for the control of high blood pressure and for the relief of psychotic symptoms. Because of the development of better synthetic drugs for these purposes and because of its numerous side effects, reserpine is rarely used today. The antihypertensive action of reserpine are a result of its ability to deplete catecholamines, among other monoamine neurotransmitters, from peripheral sympathetic nerve endings. These substances are normally involved in controlling heart rate, force of cardiac contraction, and peripheral vascular resistance. The source of reserpine is the species of Rauwolfia, for example, Rauwolfia serpentina, Rauwolfia tetraphylla, Rauwolfia micrantha, Rauwolfia nitida, etc. But in India, Rauwolfia serpentina is the main source. Reserpine contained in the roots of Rauwolfia serpentina is 0.15 to 0.2%. A total alkaloid extract may be obtained from powder root material by extracting with ethanol and or ethylene chloride. The total alkaloid extract is usually chromatographed on acid-washed alumina column. Benzene is often used as eluting solvent. Elution sequence going from benzene to a degree of solvent polarity as resulted by 10% methanol in chloroform elutes the alkaloids. Reserpine being eluted in benzene elevates isolation of reserpine. In 1947, Dutt et al. Made an extract of powdered roots of Rauwolfia serpentina with alcohol. The solvent was distilled off from the alcoholic extract, leaving in dry residue. This residue was then treated with several changes of water, after which there was left some insoluble material of water insoluble material from the ethanol soluble extract, and this was designated as oleoresin. A number of investigators found reserpine in this oleoresin fraction a few years later. During that period, there was also available commercially a fat-soluble alkaloidal fraction extracted from Rauwolfia serpentina root known as alceroxylone. A number of investigators also isolated reserpine in pure state from this alceroxylene extract. The procedure for isolating reserpine from oleoresin fraction may be summarized in the following chart. Aceroxylin 100 gram is dissolved in 170 milliliters of sodium hydroxide and stirred well with 3.5 liter of benzene for about 1 hour. It is then filtered. The solid is again stirred with benzene and again filtered, and the two filtrate, that is two benzene extracts, are mixed. They are then concentrated in vacuum to about 4.8 liter. On concentration, you get a yellow precipitate which is removed and the filtrate which contains the main alkaloid. The filtrate is reduced to dryness in vacuum, and this contains alkaloids, tannins and resins. They are dissolved in 150 ml of 2.5% acetic acid in methanol. Then ammonia is added to make the pH to 8.5. This is allowed to stand for few hours. On standing, the mother liquor contains resinamine, whereas reserpine isolate crystallizes out. The yield is about 5.3 gram. Although the use of reserpine has been discontinued, Rauwolfia is an important drug utilized in alternative systems of medicines, particularly Ayurvedic system of medicine. Module 5: Extraction and purification of sorrelin from Sorrelia corallifolia Linn. Sorrelia, also called sorrelin, is the parent compound in the family of natural products known as furanocoumarins. It is structurally related to coumarin by the addition of fused furan ring and may be considered as a derivative of umbelliferone. Sorrelin occurs naturally in the seeds of Sorrelia corallifolia as well as in the common fig, celery, parsley, West Indian satinwood, and in all citrus fruit. It is widely used in PUVA, that is sorrelin plus UVA treatment phosphoriasis. Sorrelin, crushed seed of Sorrelia corallifolia, is soaked with 50% ethyl alcohol solution, and the leaching solution is filtered and distilled to remove alcohol. A slurry of the sediment is obtained and dissolved in methyl alcohol, that is methanol, followed by treatment with active carbon for decoloration. Evaporation of methanol results in formation of laminar crystals after the sediment is kept still overnight. When methanol is applied to dilute the sticky solution after filtration, yellow crystals are obtained. Recrystallization of these crystals in methanol yield wild needles like crystals. Thin layer chromatography and high performance liquid chromatography are employed to determine the purity of resultant substances. An important use of sorrelin is in PUVA treatment for skin problems such as psoriasis and to a lesser extent eczema and vitiligo. Dear friends, in this lecture we have discussed the success story of India in production of menthol. Menthorensis, a Japanese plant, was introduced in the country. Cultivation of this species started at number of places. Technologies for economic utilization of mentha herb developed and factories for menthol production established, giving employment to people of regions where the crop is introduced. The country which used to import menthol for its industry is now one of the major exporters of mentha oil and menthol. Opium is one of the crop which is under strict government control, as it causes addiction and is a source of illicit trade and instrument of finance for terrorism. Morphine and other alkaloids of opium are of great therapeutic importance. Extraction and isolation of these alkaloids involve technologies which are based on the relative solubilities of these alkaloids in the solvents, and extraction environment because of their chemical structure. Quinine is another alkaloid present in the bark of Cinchona species. Quinine is an anti-malarial agent. Production of quinine in government factories of the country and the methods of isolation of it along with other alkaloids have been discussed. We have also discussed extraction and isolation of reserpine, which was once a very important drug for hypertension and anxiety. The source of reserpine are the roots of Rauwolfia serpentina, known as sarpagandha. Although not much in use, the authentic compound not much in use, as synthetic compounds have been developed. Reserpine has served the mankind by providing scientific knowledge of understanding these ailments. Psoralen is a furanocoumarin used in management of psoriasis. A brief note on its source and general methods of isolation was covered during the lecture. Friends, we have discussed in isolation of phytopharmaceuticals which are employed in various pharmaceutical formulations. It is always interesting to know how these are obtained.